And we're back, and you'll see we'll get C equals 13.9 degrees. You could have done the same thing, gone to the trig tables on page 925 in your book, and you could have gone down that column and said, okay, here's angle, and here's the sine functions, and gone down the table until you got to 0.24, and you would have said that's almost 14 degrees, because that would have been the closest. So you can use your trig tables and work them backwards. That's another way to do this. It just is a little more rough. We can do the same thing with the cosine here. Cosine of C is equal to 0.37. Now if I take the cosine inverse of this, I, of course, will get the same angle of 13.9 degrees. So let's look at this problem. Model train. You're building a track for a model train. You want the track to incline from the first level to the second level, 4 inches higher, so it's 4 inches up here, in 96 inches. So we've got a right triangle. Is the angle of elevation less than 3 degrees? Well, let's find the angle of elevation. So relative to this angle x, I have the opposite side and the adjacent side. And so if I'm thinking about SOHCAHTOA, I have opposite and adjacent, so I'd probably want to use the tangent function. So I'd go tangent of x equals opposite over adjacent, 4 over 96. And then I'd take the tangent inverse of that to solve for x. So tangent inverse of whatever 4 over 96 is, and I will get my answer. And when I do that, I get 2.4 degrees. So the question is the angle of elevation less than 3 degrees? And the answer is yes, it is less. So if you use inverse trig functions, it undoes sine, cosine, and tangent and tells you what the angle is. And you can do the same thing by looking at the table, finding that ratio, going down to the ratio, and reading off the angle off those trig tables on page 925. So what I would like you to do is find what angle, using the trig table for question number 1, what angle has a tangent R equal to 0.36. And tell me what R is. That's question number 1. Have a wonderful day.